Determine the non-permissible values restrictions for the following. So you have m minus 5 and then you have the 2m plus 10. Remember, your restrictions only occur in the denominator because your denominator can't be 0. But I proved to you the other day that your numerator, the top, can be 0, correct? So we just do it based on the bottom. It's not asking us to do anything other than non-permissible values, and they usually have one non-permissible value question on your diploma. I always feel like that should be your give me question, okay? So if you're finding non-permissible values hard, keep practicing them and come and get help because they're not that hard. You just obviously are missing something. So we have 2m plus 10 on the bottom. What can I take out of the 2m plus 10? What greatest common factor? 2. So then I'm left with m plus 5. Then to find my NPVs, I just split them up and say not equal to 0. So I have 2 cannot equal 0. That is true, but that doesn't give me an NPV, right? The restrictions only come when you have a variable because the variable could be a number, and we want to state all the numbers that it could be that would make the denominator be 0. So this one doesn't get us an NPV, so I just cross it out. Then I have m plus 5 cannot equal 0. How do I move the 5 over if it's a plus 5? Subtract. So I have m cannot equal negative 5. And that's my only NPV. Now I can check it. I can put it back in and see. So if I go 2 times negative 5 plus 10, I get negative 10 plus 10, which is 0. So I know I'm right. Because m can't be negative 5. Because if I plug negative 5 back in, it would get my denominator to be 0, and it can't be 0, right? That's the rule. It cannot be 0. So that's why. So you can always check them back. If they get your denominator to be 0, then you're right. You can walk away from the test knowing I got every NPV question right. Okay? D, x squared minus 49. What is that? Difference of squares. So I can actually break it up and factor it first, right? So if I take square root of x squared, I get x. Square root of 49, I get 7. So on the bottom, I'd get x in the front of the bracket, 7 at the back of the bracket, and opposite signs. Okay? So if you can take out a greatest common factor, or you can do a difference of squares, you do first before you try and find the NPVs. Now, I have x plus 7 and x minus 7 in their own brackets. Whatever's in its own brackets, I set not equal to 0. Okay? Just like I did back here. I put the 2 and the m plus 5. So here I'm going to go x plus 7 cannot equal 0, and x minus 7 cannot equal 0. And then I solve them out separately. So I'm going to subtract 7. And I'm going to get x cannot equal negative 7. And then I'm going to add 7. And I'm going to get x can't equal positive 7. So my NPVs are negative 7 and positive 7. Now the way they'll often have them written is together. So they'll write them together like this. X cannot equal plus or minus 7. Positive sign over a negative sign, 7. They don't usually have them written out separately if it's the same number. Make sense? Okay. You all have the same face, whether you're getting it or not. I have no idea. So I'm going to go with you are. Everyone, solidly. All right. So it's your turn. You try these 4. If you are stuck on something, put your hand up. I can help you. Okay. It says determine the non-permissible values or restrictions. Remember, those words are changeable. I could ask you for the restrictions, or I could ask you for non-permissible values. They mean the same thing. It's the restriction on the variable or what the variable can't be, so non-permissible. So we have 2x minus 4 over negative 2x minus 4. The numerator, the top, doesn't matter in this instance because I'm just asking you for non-permissible values. I only care about the denominator, the bottom. So you can either take out a negative 2 or not, and you should still get the same answer. I'm going to GCF because my first thing I always do, especially when you start doing all the rest of the operations that we have to do, is to GCF or factor wherever possible when you're doing simplifying or multiplying and dividing. So I just start GCFing anyways when it's a simplifying question like this. So I take a negative 2 out, and I'm left with x, because negative 2x divided by negative 2 is x. Negative 4 divided by negative 2 is a positive 2. And then I feel like it's just easier to solve. So I'm going to get 2 NPVs. I'm going to get 0, I'm going to get negative 2 can't equal 0, which doesn't get me an NPV, does it? So I actually only get one NPV. That one doesn't have a variable. So this one would be x plus 2 can't equal 0. And I move my 2 over, so I get x can't equal negative 2 by subtracting it. And that would be my NPV. Now I can check it. I can say, okay, negative 2 times negative 2 is positive 4. Positive 4 minus 4 is 0. So I know I'm right. Walk away. Happy. B, the denominator has a squared minus 81. What could I do first? Difference of squares. Exactly. Square root them. So I get myself 2 factors. The square root of a squared is a. The square root of 81 is 9. So I'm going to get an a in the front of both brackets and a 9 at the back. Plus or minus plus, it doesn't matter. And then I'm going to split it up. And I'm going to get a plus 9 cannot equal 0. A cannot equal, subtract that 9 over, negative 9. And then I'm going to get a minus 9 cannot equal 0. I'm going to add the 9. And I'm going to get a cannot equal 9. So I get negative 9 and positive 9. So I can write them together as a cannot equal plus or minus 9. Okay? C. Could I take out anything? A P. I literally moved this 2 feet back and I still hit it. True that. Okay. Oh, I just recorded true that. Awesome. So I could take out a P. Someone said correct before I body checked that thing over there. Okay. Take a P out and I'm left with 4P minus 0? 1. Yes, thank you. Okay. Then we split it up and we have P cannot equal 0. And that brings happiness to all people everywhere, just like Christmas. Look, it's done. Yay. Then this one brings a little hardship, but you'll be okay. You'll work through it. 4P minus 1 cannot equal 0. So I have to solve it. I have to use my solving skills, which sometimes that's the lacking thing after maybe not doing it math for a year, right? Solving skills drop out and leave the building. So what do I have to move first? Yeah. Yes, that was like teamwork. You two like just totally minus and yeah, good. Plus 1. So you get 4P equals 1. And then, no. And then you need to get P by itself. So what are you going to do? Divide the 4. Because it's being multiplied, right? Sometimes it's just getting back into the math mode. So P cannot equal a quarter. So I actually have 2 NPVs. P cannot equal 0 or a quarter. And I'm going to put them together and nicely box them because when Mrs. Lepp is like marking, she would be like so happy. They're like together. She's so nice. You know? Brings happiness. Except for when you like do one over here and then one over here and then one randomly up here and you put an arrow, that doesn't bring as much happiness. Okay? Happiness. D. D is the tricky one I told you. And if you got it right, I'm impressed. If you didn't get it right, don't worry, because I think that you shouldn't probably get it right on the first one because it's tricky. So we have 2x squared plus 8. I could take out a 2, and I'm left with an x squared plus 4. Now, watch yourself. Remember I told you that if you have a difference of squares, so a subtraction sign, you can actually factor it, right? But if you have an addition of squares, you can't factor it. You can't go into 2 brackets. Don't do that. You just can't do it. Okay? It's not possible. Even if you try, when you go to put it back together, say you get 2 factors, when you go to put it back together, you're not ever going to get x squared plus 4, no matter what way you tried to factor it. Keeping the same signs, different signs, it doesn't matter. So that's as far as you can go with an addition. Now, the catch 2 is you'd have 2 can't equal 0, which is true, but doesn't get me an NPV. Then you get x squared plus 4. I told you can't factor it. So this is as good as it gets. So I'm going to try and solve it. I'm going to subtract my 4, and then I'm going to get x squared can't equal negative 4. And when I take the square root of it, I have to remember to take the plus or minus of the square root. Okay, so whenever I take that square root sign, you're going to get a positive or negative sign in front of it. So you'd actually get 2 NPVs. But in this case, do we actually get 2 NPVs? Can you take the square root of a negative number? No, you're not going to have any NPVs. There are no NPVs. And now I'll explain to you why. Any x value I fill into this squared, whether it's a positive or negative value. If I square a positive or negative value, what do I get? A positive. So if I square a -1, it's positive. If I square a -12, it's positive. If I square a +4, it's positive, right? So if I go 2 times any positive number, will it ever cancel off +8? I need that +8 to go away because I need the denominator to be 0 in order to get an NPV. So if I would need this to be a -8, this 2x squared somehow would have to be a -8 in order for me to get an NPV, right? And it can't. That x squared is always going to give me a positive number. There's no way I could ever make this denominator be 0 by filling in any value for x. So if there's no value of x I can fill in to make that denominator be 0, then there's no NPVs. So it's kind of a trickery of a question. I'm going to get you to work on a few questions out of your textbook, and then we're going to come back to this. So the homework is page 223, number 3, 9A, 10, 11A, and 16. Remember, you want to work consistently in class because then you don't get any homework.